On behalf of the UNC Cleantech Summit, please join me in welcoming Val Miftakhov, founder and CEO of Zero Avia, the first practical zero-emission aviation powertrain. We are thrilled to have Val with us to share more about the impact of renewable hydrogen on aviation. During his career, Val has looked to technology for new ways to help the world. Prior to founding Zero Avia, he founded eMotorworks and developed the world's leading platform for EV battery aggregation to provide grid services. Also, Val has held senior positions with Google and McKinsey and has multiple degrees, including a PhD in physics from Princeton University. Welcome, Val, and take it away.
Thank you, Kirsten. Appreciate being here. Thank you for the invites. And indeed, aviation is the next frontier of clean transportation, and we at Zero Avia are looking to play a leading role in it. So we started a company about 4 years ago, and our objective is to move aviation, commercial aviation, to a clean future and avoid becoming the largest source of human climate impact by 2050. So I'll walk you through how we do it, what we're planning to do, and how we're going to bring aviation to this new future. So why we're doing this, we think there is moral imperative for action for aviation industry. Of course, all of us are familiar with the climate change effects all over the world, and I'm not going to repeat that. Preaching to the choir, I'm sure. But on the lower right of this chart, you see the graph that tells you a story about how important it is to bring change to aviation industry specifically. So today, we in aviation industry are a relatively minor portion of the total human climate impact overall, anywhere between 5 and 10%. The CO2 portion of it is actually even smaller, 2.5 to 3%. And you get to 5 to 10% through all the non-CO2 factors, like high altitude emissions of particulates from burning jet fuel, nitrogen oxide, high temperature water vapor. There is a consensus now among academia and a big part of the industry that these non-CO2 factors add at least the same amount of climate impact that CO2 has. So you take that 5 to 10%, which is still not super significant, but then you look at the growth rates of aviation, and everybody wants to get on the plane to go different places, meet new people, conduct new business, or go back to your family. And throughout the world, when per capita income hits certain values, people get on the plane and they go. So the growth rate of aviation is quite high. In normal times, pre-pandemic, between 5 and 7% year over year, depending on the segment. So you take that and you project that to 2050, you'll see that as business as usual, aviation can get to 25 to 50% of the total human climate impact. And of course, that would be a disaster. And in fact, we think that the disruption in the industry would come long before that, either through technology, and that's what we're trying to do, or through the regulatory action. When if nothing is done on the technology side and the trajectory is like this, then regulators will just clamp down on aviation, as they're already starting doing in places like France, for example, where there are already restrictions on regional flights in favor of rail. So we really don't want that to happen, because we think, and I think personally, that aviation provides a very important service and very important enabler of human activity. So really want to see aviation thrive, but it needs to solve its sustainability problem. So that was the motivation for starting the company. And we wanted to go after the commercial aviation first and foremost, so large aircraft, fixed wing aircraft or airplanes. So then we spent a lot of time thinking about how we're going to do it. And we looked at all the technologies. We got a number of PhDs in the founding team, physics, chemistry, and so forth. And we looked at 5 different ways to achieve this, from battery electric to hydrogen electric. So really quickly going through these options. Battery electric, just batteries are too heavy, and we could not see, with the theoretical limitations of the batteries, we could not see them being relevant for large commercial aircraft. And we're talking about at a minimum, let's say 50 seat and above, and we just can't see it being commercially viable or physically viable for that matter. Then you look at hybrid electric, which is definitely possible to do, but unfortunately quite an incremental impact. So estimates out there suggest maybe 15% improvement on the efficiency side, which is, if you think about the growth rate of aviation being 5 to 7%, that just buys you 3 years, right? And then what? And we're talking about 20, 50, 30-year time horizons. So really the impact is not there. Then you go into the sustainable aviation fuels, which has 2 components. One is the biofuels, biostock. So you grow something and then you make fuel out of it. That part is not really scalable. If you think about the volume of fuel, especially again with the growth of aviation, think about volume of fuel that you would need in order to convert the majority of aviation to that fuel. You'll run into land issues, water use issues, and economics as well. So you're really, sustainable aviation fuels, the component that makes sense scalability-wise is synthetic fuels, which start with green hydrogen and then add CO2 from direct air capture, for example, and produce liquid fuel replacement for kerosene in a large-scale facility that's not dissimilar to current refineries, for example, oil refineries. That has a lot of cost in that process. And as a result, synthetic fuels are always going to be more expensive than hydrogen as fuel, if you can use hydrogen as fuel, because again, synthetic fuels start with hydrogen. So that's why we think that direct hydrogen approaches, where you take hydrogen and use it as fuel directly on board the aircraft, are going to be the most economical ways to move aviation to the new future. And in those, there are two points, or 2 versions. One is you can combust hydrogen or burn hydrogen in the turbines that are similar to the existing turbines out there. And that definitely has a potential. Unfortunately, you're still going to have all the known CO2 effects of combustion, which is nitrogen oxides and high temperature water emissions, water vapor emissions, even more so than with jet fuel. So you're going to have all those impacts still there. And lastly, the efficiency of combustion is much lower than what you could get from the last item here on this table, which is hydrogen electric. And hydrogen electric is, you store hydrogen on board the aircraft, you then use it in a fuel cell that combines hydrogen and oxygen, but not in combustion cycle, but rather catalytic electrochemical reaction to produce electricity. And then you run electricity into the electric motors to very efficiently convert it into propulsion. So the efficiency of hydrogen electric for medium-sized aircraft, like a 50 to 80 seat aircraft that's behind me here on the background, is twice that of a turbine. So you need half the fuel that you would need for hydrogen turbine, which means that your costs are going to be much lower. And on top of the fuel cost reduction, you'll also have the maintenance cost reduction because there is no high temperature combustion, and electric motors, as we all know from the car industry, for example, are quite low in maintenance. So that's why we think that hydrogen electric approach is the best approach to bring aviation to this new future. And therefore, the vision of our company, Zero Avia, is to pioneer that hydrogen electric aviation approach for the whole industry. And we believe that we can get not only zero emission through this, but also long range and lower costs, which is really, the economics is really the parts that makes us excited about the long-term scalability of this business. Because in the end, the technology will get adopted if it results in better economics for people. So over the last 4 years, we have moved quite a bit towards that. So started the company in 2017, went through 3 rounds of funding so far, raised over $100 million in from private sources, 20 million from public support from the grants. We have flown a number of prototypes, about to fly a 20-seat prototype, and next year we'll fly a 70-seat prototype with our engines in it. Overall, through the segments, we think that this technology, hydrogen electric, will be applicable to all segments of aviation. Right now, we're working actively on the first 2. So the first commercial offering in 2024 with 20-seat aircraft, 10 to 20-seat aircraft. And then 2026 in a 50 to 80 or 40 to 80 seat aircraft. And those 2 programs are in progress right now with the company. Test flights of the 20-seater are imminent in the next few weeks out of our UK facility, and in summer out of our US facility. And 2026, the first prototype flights next year. So really working on this right now. We have also built the fuel infrastructure, the first examples of fuel infrastructure at our UK R&D facility, which shows the full cycle of renewable electricity production, hydrogen production for electrolysis, and then utilization in the aircraft. And then over time, we'll move to larger aircraft, larger and larger facilities. For our first prototypes that we've flown, and those were at the time in 2019 when we first flown our first prototype, it was the largest zero emission aircraft in the air worldwide. And then in 2020, we flew our second prototype, and it became the world's largest hydrogen electric aircraft in the air. We built all the systems ourselves, put them together, built avionics, software, and ran the test flight program. Built the renewable hydrogen production on site in our facility at Cranfield University in the UK as well, make our own fuel for all our tests. And today, the test programs accelerate and continues. On the left side here, our test program for 10 to 20 seat engines. We've done all the ground tests and now preparing for flight tests there. Again, marked introduction in 2024. On the right side, the large engine program or larger engine program, 2 to 5 megawatt class, will have the first full thrust demonstrations on the grounds later this year, and then flight tests next year with certification and entry into service in 2026. We just also opened our great R&D facility in Seattle area. So it's co-located with our great partner, Alaska Airlines, that we've announced just a couple of months ago. And Alaska became an investor in the company and also a partner on the development side and a partner on the operating facilities side. One of their operating bases is in the Seattle area and Payne Fields, and that's where we have our next R&D facility in the US. Overall, across all commercial arrangements and agreements, we have the best traction, the most extensive traction of any zero emission aircraft companies out there. More specifically, United Airlines, Alaska Airlines, British Airways, and a number of lessors and a number of other operators have already signed up to take up our engines to retrofit the existing aircraft and line fit the new aircraft that they are operating. We have a number of relationships with the aircraft OEMs as well that we have announced, covering a number of segments that we're planning to operate in, including the 19-seat segment or 20-seat 19-passenger segments, the 40 to 90-seat segment with de Havilland Canada on the turboprop side, and that segment on regional jets with Mitsubishi Heavy Industries regional jet division. all of these relationships show the commitment of the markets, of the ecosystem to this type of approach. And more, we see the support for hydrogen electric across the board. And we're really the company that's leading that approach. From the investor side, great support as well. We got Bill Gates and his Breakthrough Energy Ventures as one of the lead investors for the company. Amazon Climate Change or Climate Impact Funds is a core investor as well. Shell Ventures brings support on the strategic side for the hydrogen production and infrastructure, and a number of other investors with the sustainability in mind. We also have great support, of course, from the UK government through Aerospace Technology Institute that helped us push, especially in the UK, push our R&D program. On the team side, real quick, great experience from the previous companies that we have collectively started and built, and a number of industry veterans that joined the company from various aerospace companies pushing us forward. Great support from the great advisory boards, from the operators to the airframers and the regulators. Fueling providers, so great, well-rounded support from the advisory board that allows us to move very, very quickly towards the goals that we have. So this is what Zero Avia is doing, and this is where we're at. And if I have to say one thing to leave you all with is that commercial zero-emission aviation, true zero-emission aviation through hydrogen electric is coming sooner than most expect. And in 2024, 2025, you'll be able to buy your first tickets to hydrogen electric aircraft powered by Zero Avia. Thank you very much.